Great. So our final speaker before lunch is Racquel Maronde. And Racquel is a diving and rugby enthusiast with a myriad of marine interests from coral ecology to little blue penguins. She's joined us from Minnesota and is extremely excited to showcase her skill set and Capstone project. So the name of her project today is Where the Wastewater Goes, a story of wastewater challenges, impacts, and management in St. Croix, U.S. Virgin Islands.
Do you know where it goes? My story today is titled Where the Wastewater Goes, a project that examines the wastewater challenges, impacts, and resources in St. Croix, U.S. Virgin Islands. Part 1, Setting the Scene. This story takes place in the U.S. Virgin Islands in the Caribbean, just east of Puerto Rico. There are 3 main islands in the territory, but we'll be focusing on the largest and the most populated island, St. Croix, with 84 square miles of land and around 50,000 residents. This island is also surrounded by extensive and important coral reef ecosystems, from long linear reefs to scattered patch reefs. The main characters of our story will be wastewater, water used by humans, industrial, domestic, or commercial. Sewage, which is human waste transported through a sewer. Black water, a product from toilets. We all know what that is. Gray water, a product from washing, dishes, clothes, bathing, etc. And although there are other major sources of land-based pollution in St. Croix and other types of wastewater, this story focuses solely on the mentioned characters of sewage, black water, and gray water. Black and gray wastewater contain harmful pathogens, bacteria, and nutrients, including Enterococcus, fecal coliform, which is inclusive of E. coli, and inorganic nutrients such as nitrate, nitrite, and phosphate. It's important to note that this illustration shows a type of point source pollution or a direct discharge of wastewater, when in reality, most wastewater in St. Croix actually comes from non-point source pollution or indirect discharge from stormwater runoff or sewage leaks. These excess nutrients from sewage can cause what's called eutrophication. Eutrophication encourages macroalgae growth, which can smother corals by depriving them of oxygen, sunlight, and space. In St. Croix, the consistent contamination from land-based pollution, such as sewage, has increased eutrophication and algae cover. In addition to nutrients, the pathogens, bacteria, and suspended solids carried in wastewater can impair coral reproduction and tissue growth, as well as increasing its susceptibility to coral diseases. With the compounding impacts of global stressors such as climate change, regional stressors such as stony coral tissue loss disease, and the local stressor of wastewater pollution, corals in the Virgin Islands are more susceptible to coral disease now more than ever. Wastewater pollution also poses a serious threat to human health. Those who come in contact with polluted waters are at a higher risk of developing gastrointestinal, chest, ear, or eye infections, and/or even hepatitis. Additional health risks include antibiotic resistance, contaminated seafood, or drinking polluted waters. Coral reefs in general provide deep intrinsic value and essential biodiversity. In the U.S. Virgin Islands, many people come seeking of a reef-related adventure to catch a glimpse of this amazing biodiversity. There I am again. The territory's reefs have thus become an essential component of their tourism industry and economy, with an estimated $275.6 million. Additionally, these same reefs act as actual underwater barriers to storms or hurricanes, saving an estimated of $47 million in averted damages from flooding. Intrinsically and economically, the territory's coral reefs are essential ecosystems. St. Croix and the rest of the territory unfortunately does have a history of wastewater infrastructure failure and septic system inadequacy, causing raw sewage to enter coastal waters and ultimately violating the Federal Clean Water Act. This brings me, there is a lot of amazing information for water quality, wastewater, and coral reef management in the U.S. Virgin Islands. This information, however, is disconnected and scattered, or it's a 300-page report that maybe some people will reference. And I have gone through this literature to help empower environmental engineers, natural resource managers, and quite possibly St. Croix residents. This brings me to part 2, my project. The objectives of my project is to synthesize information, resources, and ideas into one guiding source, to empower and connect residents, business owners, managers, planners, and decision makers to establish a unified understanding of wastewater management, challenges, and needs. The ultimate goal, of course, is to minimize wastewater pollution in St. Croix to reduce impacts on coral reefs and public health. The process. First, I informally met with and interviewed professionals from various agencies and organizations, such as the VR Department of Planning and Natural Resources and the local Coral Bay Community Council. These 16 individuals provided additional contacts and resources, literature, ideas, and most of all, everyone was really excited to talk about poop and water with me. And there was so much encouragement, so it was really great. Secondly, I also conducted a literature review of these numerous reports and papers and legislations so that I could best understand what information is actually available for everyone. Lastly, I did some data manipulation. For example, I took over 100 weekly beach advisories and transformed them into one Excel file, and then entered it into GIS to create a visual representation of which beaches have been impaired over time. So, what came of these interviews, literature review, and data manipulation? The first and largest portion of my project is this report. I wanted to provide a narrative with attractive and digestible information for various audiences to reference. And in case an audience wasn't quite convinced that the topic was relevant, I made sure they were aware that wastewater pollution is everyone's problem, because everyone poops. Other examples of report components include the current situation, which outlines present water quality programs such as the Water Pollution Control Program, monitored by the Department of Planning and Natural Resources. Other pages can include various content from how wastewater pollutants actually impact corals and the positive feedback loop that occurs, to the infrastructural challenges that Waste Management Authority faces. Towards the end of the guide, you'll find the resources section. This section dissects and divides resources into relevant reports or investigative documents, pertinent papers, management plans, and online resources. And if you take a look in the management plan, you'll see an area that says focus and cute little cartoons. The yellow's a coral, there's a wastewater icon, and there's a water icon. And again, this is just for people to look at as a snapshot to think, oh, that might be relevant to what I'm looking for. Maybe this combines wastewater and corals as well. We'll take a break from our main story, and we'll take a side journey into the other component of my project, a story map, that was built to complement the guide and provide spatial, temporal, and interactive information. Today we'll go on a tour of the story map to examine wastewater infrastructure, soil suitability, and an example of a water quality impairment in St. Croix. Authority centralized wastewater infrastructure. There are at least 90 miles of sewer lines, 14 pump stations, and one major wastewater treatment plant. Notice the infrastructure is all placed in low-lying areas, an obvious sign of the topographical challenges FEMA faces in connecting to all residents. Here we have conventional and alternative on-site sewage disposal systems, or more commonly referred to as septic systems. OSD systems are a very important piece to St. Croix's wastewater story, as unsuitable and failing OSDS are a major cause of wastewater pollution. The important thing to understand here is that residential wastewater goes through some sort of system. Whether it's a septic system alone or with alternative technology, it is then dispersed into some sort of drainage field. So, why does an OSDS fail, you ask? Great question. There are many reasons an OSDS can fail, but an island-wide challenge is finding the right soils. The soils of St. Croix are incredibly important when it comes to absorbing stormwater and filtering OSDS wastewater. Soil type and depth will dictate the success or failure of an OSDS. Let's take a look at what St. Croix is working with. I see a lot of yellow and gray and a little bit of blue. The blue group, or group B, has moderate infiltration and runoff. The yellow group, or group C, has low infiltration and moderately high runoff. The gray group, or group D, has very low infiltration and high runoff. This isn't the best situation for an on-site sewage disposal system, which relies heavily on high infiltration to properly treat the wastewater and low runoff so as to avoid any untreated sewage joining stormwater runoff. Zooming in, we can look at each estate line on St. Croix and better examine what soil types are available for residents. In St. Croix, they periodically measure coastal waters and different bodies of water for certain impairments, Enterococcus being one of those impairments. Enterococcus is a fecal indicator bacteria which is utilized to assess fecal contamination. The allowable amount of Enterococci is 70 per 100 milliliters of water. So, anything that is above 70 is considered impaired. And here you can see it goes from 70 to 300 and above 300. Now, there are a lot of other conditions that are measured in St. Croix when considering impairments, such as fecal coliform. There's turbidity, dissolved oxygen, phosphorus, nitrogen, nitrate, clarity, Secchi depth, all of these words. All of these things are measuring different types of impairments and have their very own allowable measurable impairment amounts.
And you thought this presentation would just be about poop. Nope. The truth is that this topic and my project demand expertise from a myriad of otherwise disconnected fields. From understanding wastewater infrastructure and engineering to water quality legislation and monitoring, there are a lot of moving pieces, in which it is important that we must think creatively to solve the problem by forging partnerships with human health organizations, sewage infrastructure and treatment experts, entrepreneurial groups, and development and environmental conservation organizations. Sewage pollution is a global threat that humans and coral reefs share. Combining forces across organizations in traditionally non-interacting sectors is essential if we are to address the strain of human sewage in our reef systems and their associated human communities. Which brings me to part 3, the falling action. Moving forward, this guide and story map of where the wastewater goes may act as a reference point for those human health organizations, for those sewage infrastructure experts, and for environmental groups in order to best understand the entire story and to better understand the connections between wastewater pollution, coral reefs, and human health. I'd like to give a big thank you to the supporting characters of this story, the chair of my committee, Dr. Ashley Lillis, Dr. Amelia Wegner, Caroline Pott, and Dr. Brian Zaglinski. Said it right, I think. Other
supporting organizations that were a massive help was the Department of Planning and Natural Resources, the Coral Bay Community Council, which provided stellar wastewater workshops and was a wealth of information for me, the University of the Virgin Islands, and the EPA, which provided some historical and legislative background on the region, as well as other individual consultants and representatives. The end. Questions? I know it's scary to talk about poop. Oh, is there a question up? Miss Tammy Russell, go. Why did you pick St. Croix? Great question.
That was awesome, Racquel. Good job. Very artistic, too. Impressive. I'm just wondering if people are monitoring the coral reefs and if these overlays of the maps correlate with impacts on the coral, or if that's something that could be incorporated in further.
Yeah, that's a really good question. So that was actually a component of my project, was to enter all the raw data of these water quality conditions because they are measured. But from what I've found, I haven't necessarily seen that data overlaid with corals yet. And that was a component of my story map that I would like to incorporate, because that's kind of a really important component, is comparing things like fecal indicator bacteria with the local coral reefs, as well as the presence of stony coral tissue loss disease. Although that disease is not caused by wastewater pollution necessarily, it's still like a really in-depth investigation of where that has come from. But yeah, that's really vital information that I would like to continue to work on. Yeah.
Thank you for the presentation. I was curious if you had any stats on the wastewater facility. I realize some of the issues are from the non-point sources, but have they looked at doing cogeneration of power, water recycling, anything along those lines? And if so, I'd be happy to talk
Great
with you more
question.
about that.
No. No. VEMA has, VEMA, which is the Virgin Islands Waste Management Authority, they were established in 2004 as part of several consent decrees from the US federal court in order to bring the territory in compliance. Now, with that establishment, they actually inherited decades, like maybe 60 to 100 years old infrastructure that's very outdated and very broken. And right now they do suffer with a lot of capacity challenges. And so they are kind of in a triage mode where they are doing the best that they can to adequately fix the problems at hand. So I haven't heard those conversations, and through my research, I haven't seen those conversations. Mm-hmm.